subscribe to my channel, watch the video, try to share the video, comment, especially subscribe to the channel so that anytime there's a new video you can get alert. So in our previous video we've discussed everything on ionic bonds, okay, the various types of chemical bonds. We talk about ionic bonds, covalent bonds, and today in this video we are going to talk about metallic bonds. So let's talk about metallic bonding. So here, anytime we're talking about metallic bond, what should come into your mind is a metal. In this case, we can say it is the electrostatic force of attraction between a fixed metal, this is a fixed metal ion. Okay, so why are we saying electrostatic force of attraction? Electrostatic in the sense that when we were learning about ionic bond formation, we said that there is a force of attraction called electrostatic force of attraction. This force happens when there is positively and negative charge species. And in these metallic bonds too, you can see a positively charged, a fixed positively charged ion and a delocalized electron. So we can say that it is the electrostatic force of attraction between a fixed positive ion, okay, a fixed positive ion and a delocalized electron around the cation. So that force of attraction existing between this fixed cation and a delocalized electron is what we call metallic bonding. So metallic bonding is simply defined as the electrostatic force of attraction between a fixed metallic ion and a delocalized electron around the cation. So that delocalized electron is around this cation. So that is the meaning of, or the definition of metallic bonding. Now, we are using the word delocalized electron. Either you use the word delocalized or sea of electrons, or someone use the word mobile electrons. These electrons are movable, they move. So we are saying that for this type of metallic bond to occur, there should be these delocalized electrons around this fixed cation. Alright, now what are some of the conditions that we need to consider anytime we're talking about metallic bonding? Anytime we are talking about metallic bonding, there are two main factors to consider, or things that determine the strength of a metallic bond. Basically, the first one you have to look at is what we call atomic radius. Or atomic size. And then we look at what we call the delocalized electrons. So these are the two main factors to consider when it comes to the strength of metallic bonds. So for metallic bonds to occur, we basically consider these two main factors, the atomic size and then the delocalized electrons. Now what can we say about atomic size? There are so many interesting questions that can be asked on this metallic bonding, and we need to understand the concept very well. Now, when you pick the periodic table, for instance, when I do this, it means that you are moving down the group from top to bottom of the periodic table. So when you are moving down the group, or when you are moving from left to right on the periodic table, what happens to the atomic size? Okay, so anytime we are moving down the group, you know atomic radius increases, the atomic size increases. Okay, so moving down the group, metallic bond strength decreases. When you are moving down the group, metallic bond strength decreases. Why is it decreasing? Because once we move down the group, the atomic size will increase. What it means is that anytime there's a bigger atomic size, if your atomic size is big, it means that your metallic bond strength will be very low. Let's give a typical example. For instance, when I'm moving down the group, I have something like lithium. Okay, sodium is here. Okay, potassium. Okay, all these elements, we can say these elements are group 1 elements or alkali metals. Now, once I move down this group, we are saying that the atomic size of this will be increasing. Lithium is smaller compared to sodium. It means that sodium is bigger than lithium. Potassium is also what? Bigger than sodium. So when you move down to maybe looking at cesium, you realize they're very big compared to the rest. Now, what we are trying to say here is that whilst I'm moving down this group, this atomic size, since the atomic size is increasing, the atomic size is becoming so big. The bigger the atomic radius, the smaller the metallic bond strength. So what it means is that if your atomic size is very small, your metallic bond strength is also very high. That is the meaning. So whenever we are moving down the group, the metallic bond strength decreases. Decreases means that from the highest to the lowest. So it means that here lithium will have the highest, followed by sodium, followed by what? Potassium. Decrease in the sense that it's moving from the highest to the lowest. So here, in actual sense, whenever we talk about metallic strength, we need to look at some properties of metals. The various properties of metals we can talk about is to talk about metals are what? They are good conductors of heat and electricity. We can also say that these metals are malleable. Okay, meaning they can be beaten into different shapes. These metals are ductile. What it means is that these metals can be drawn into wires. These metals have tensile strength. Okay, they resist breakage. Okay, these metals, when they are polished on their polished surface, they shine. So we can say they are lustrous. They are lustrous. So they are sonorous. They at times give us sound. So all these are some properties of metals. And for you to know the metallic strength of a metal, what it means is that it determines the boiling and the melting point of that metal. For instance, if you are having a stronger metallic bond strength, it means that you will be having a higher melting point or a higher boiling point. But if you are having a smaller melting or a smaller boiling point, it means that this particular, let's look at this for instance, lithium, sodium, and potassium. We can ask you to arrange these elements in their increasing melting point or boiling point. Increasing means from the smallest to the highest, and decreasing means from the highest to the smallest. Decrease meaning it's very big and it's decreasing from the highest to the smallest. So we are saying that whenever we are moving down the group on the periodic table, we are saying that this metallic bond strength decreases. What it means is that decrease means from the highest to the lowest. So it means that lithium, if you consider lithium chloride, sodium chloride, and potassium chloride. I can ask you to arrange these elements in increasing boiling point, given reasons. In this case, you can use the metallic bond strength to explain. You realize that all these compounds, all of them are having what? Chlorine, chlorine, chlorine. So the main emphasis is going to be on the metals. And all these metals belong to the same what? Group. They are alkali metals. And you realize that, sorry, did I say they are alkali metals? Yes, they are group 1 elements. So they are alkali metals. You realize that these metals, although they are all soft, but some are softer than the others. How do you determine that? We are saying that once you move down, this metallic strength of the metallic strength will decrease. So meaning lithium chloride has a higher boiling point than sodium chloride. And sodium chloride also has a higher boiling point than potassium chloride. Either you use boiling points or melting points. What it also implies that this lithium chloride has a higher melting point than sodium chloride and potassium chloride. And the reason is because once you move down the group, atomic size increases. The bigger the atomic size, the smaller the metallic bond strength. The smaller the atomic size, the bigger the metallic bond strength. So that is the concept under when you are moving down the group. Now what of when you are moving from left to right on the periodic table? Like sodium, magnesium, aluminium. Here when you are moving from left to right on the periodic table, or when you are moving across the period, we can say that metallic bond strength increases. Increases means that from the smallest to the biggest. So what it means is that when I pick something like sodium chloride, magnesium chloride, and aluminium chloride, what it means is that for metallic bond strength in this particular example, the metallic bond strength of these will be what? Increasing. Increasing means that from the smallest to the highest. So it means that this sodium chloride has the least or the smallest or the lowest melting point, followed by magnesium chloride, followed by aluminum chloride. What it means is that anytime we are moving from left to right on the periodic table, what happens to the atomic size? In this case, atomic size will what? Will decrease. Whilst it's moving down the group, atomic size is increasing. When we are moving across the period from left to right, atomic size what? Decreases. So whilst it is decreasing in size, the smaller the size, we said the smaller the size, the higher the metallic bond strength. So here, this sodium is bigger than magnesium. Magnesium is also bigger than what? Aluminium. So it means that aluminium is having the smallest atomic size. Therefore, since its atomic size is very small, it also means that its metallic bond strength will be high. So what we have to understand is that when you are moving from left to right on a periodic table or moving across the period, metallic bond strength increases. So we can be given this question and we'll be asked to arrange this element or these compounds in increasing metallic bond strength or in increasing boiling or melting points. So when you're asked, they will ask to arrange the following compounds in increasing melting point given reason. In this case, the arrangement will be such that we can say that sodium chloride is less magnesium chloride, is less aluminum chloride. This is increasing boiling or melting point. increasing boiling point. What it implies is that this sodium chloride is softer than magnesium